Well, see, first thing that comes as a big shocker in as when we as examiners we look at is the simple integrations of sine squared x, cos squared x, sine squared 4x, cos squared x by 2. These kind of integrals students sometimes don't get. Now, what's the strategy out here? Why it is something that we need to address it separately? Is because for a reason, lots of kids, firstly, the common mistakes that I'm telling you is that comes to our mind, and the intuition is that, okay, like how we have x squared function, they believe that this is x cube over 3 function, something like that. Now, if I have sine squared x, their integral is actually sine cube x over 3, which is absolutely incorrect. Now, how do we tackle this? Like why they become so important for uh, our calculus? Now, if you see this kind of integrals like evolve into lots of times in higher level when you're doing integration by substitution technique, um, or for that matter, like even as for 4 or 5 marker questions, this can be assessed. So now what happened is that this is something which is you will notice in several areas, like when we will be doing application of integrals such as volume of rotation and area under the graph. You'll notice such things are very vital. Now we have a little different strategy for sine squared function, cos squared function and all. So squared functions of sine, cos, you need to understand that you need to evolve, you need to integrate using the technique that I'm giving. Now, there is no direct formula for sine square x integration. So, or any power of a sine function or cos function. We don't have any direct formula for sine cube x integral or sine raised to 6x integral. So we have to use multiple techniques right from double angle formulas using complex identities. We're going to take some questions later part in the later half using complex identities. How do we integrate using complex numbers rules? So let us first take an example where you have to integrate like the same function sine squared x. So first thing is that when you have sine squared x, you never ever directly do what we did, sine cube x over 3. That's not how it is. So we use the double angle formulas for sine, which we know. So obviously that there are 3 formulas for cos 2x. So cos 2x is, if we know it is cos squared x minus sine squared x. This is very little helpful. Sometimes it can be. Next one is 2 cos squared x minus 1. And third one is 1 minus 2 sine squared x. Now, what we do is from here, we make sine squared the subject. So if I make sine squared the subject, I take the third identity. When I'm integrating cos sine squared x, what I'm going to do is I'm going to take make sine squared x the subject from here. So I'll get 2 sine squared x equals to 1 minus cos 2x. And from here you get sine squared x is 1 minus cos 2x over 2. So this is your first step of the integration. Now after this, what we do is we're gonna take, instead of sine squared x, we're gonna take 1 minus cos 2x over 2. Now the good thing is that you couldn't integrate this, and now this is something that can be integrated easily. If I take half outside, we get integration of 1 minus cos 2x. And now if I integrate this, integration of 1, we all know will be x minus integration of cos 2x is going to be sine 2x. Don't forget to divide by the coefficient of x as we discussed in our last time, plus c. So this is just a reminder, if you have integration of sine ax plus b or something, it is negative cos ax plus b over divided by coefficient of x, which is a. If you have cos ax plus b, integration of this is kind of a negative sine ax plus b over a. I mean positive sine x plus b over a. So this is just a simple way of integrating and evaluating the integral of sine squared x function. So generally, when you get sine squared x, keep it in your mind. The substitution for sine squared x is 1 minus cos 2x upon 2. Similarly, when you get the integration of cos squared x, like for example, the next up is, which is I'm going to take a different color, I will use this identity. So if I make cos 2x the subject from, cos squared x the subject from here, we get 2 cos squared x minus 1. We get cos squared x will be 1 plus cos 2x over 2. So 1 plus cos 2x over 2. So that comes out here. So it'll be 1 plus, instead of cos square x, I can substitute 1 plus cos 2x over 2. Now, instead of minus, this is plus. So only thing is that this will become plus as you integrate. So this is how you integrate sine squared x, cos squared x. Now the little trick is when you integrate sine squared 4x. So how do we tackle this kind of question? Now, once again, we use the same identity that if you have sine squared x, I would replace with 1 minus cos 2x over 2. I would remember this as a double angle formula itself. Now, if you have sine squared 4x, now if it was x, it is 2x here. So if it is sine squared 4x, now remember that your angle is 4 times, so it'll become, in the answer, it'll become 1 minus cos 2 times 4x over 2, which is 1 minus cos 8x over 2. And now when you integrate this, what happens is, if I integrate 1 minus cos 8x over 2, first thing that comes is integration. You could take 1 outside, or you could take here itself. So half I can take outside. An integration of 1 minus cos 8x. And integral of 1 is x. So it will be x. Integration of cos 8x will be negative, sine 8x upon 8. Negative is already here. And plus c. So this is how you do the basic integration of sine squared cos squared function. Now let's take the last one. Now when you have cos squared x over 2, I want to integrate this one. So in cos squared x over 2 integration, once again, if it is x, it is 2x here. So in place of this, if I put it, will be 1 plus cos star 2 times x over 2 over 2. So like how we did here. So instead of x, it is 4x. So this and this cancels. So cos squared x over 2 can be written as cos x 1 plus cos x over 2. This can be one of the interesting identity in the trig functions also. So this, you got to know this part. Now when I integrate this part, what we get is integration of 1 plus cos x over 2. And then this can be taken out, half can be taken out. Integration of 1 is x, cos x is negative sine x, positive sine x, and plus c. So this is the integration of sine squared x function, cos squared x function, and any multiple of the square, like for example, sine squared 4x, cos squared 4x, and so on.